Hi everyone, welcome to the next lecture of Turing machines. So in the last class we have seen two Turing machines, right? So today's class we are going to continue that Turing machines lecture. Okay. So this is the QR code of my compiler design textbook. This will be helpful for BTech, MTech and GATE. You can buy it from PW store, scan this QR code, okay? And this is the QR code of my Telegram channel. You can join the Telegram channel. We have a lot of discussions there, okay? And now in the previous class we have seen Turing machines, and in today's class also we are going to see Turing machines, right? So tell me, what is the language accepted by this Turing machine? So in the last class we have done detailed analysis of Turing machines. You should be able to do this easily, okay? So tell me, what is the language accepted by this Turing machine? Okay, Q naught on seeing a, leaving it as A and moving right, and on seeing a B, leaving it as B and moving right, and it is going to Q1, and Q1 on seeing a, leaving it as A and moving right, and on seeing a B, it is leaving it as B and moving right, and finally it is going into QF. Finally it is going into QF. What is the language accepted by this Turing machine? What is the language accepted by this Turing machine? That's the question. Okay. Tell me, what is the language accepted by this Turing machine? Tell me, what is the language accepted by this Turing machine, right? You can guess it easily. We have seen two examples. Now it is easy for you to guess the answer. Now it is easy for you to guess the answer, right? It is easy for you to guess the answer, right? So what is the language? Now it is taking any number of A's and then a B, any number of A's and then a B, and after that whatever you get, you are going to halt in QF. After this B, whatever you get, you are going to halt in QF. You are going to halt in QF, right? After that, whatever you are going to get, you are going to halt in QF, right? So what is the language? So the language accepted by this is A star followed by a B followed by a star followed by a B, and after that B, whatever you get, you are going to accept it, right? So A plus B star. This is important. After the B, whatever we get, we are going to accept it, right? Now let me just do a small modification to this Turing machine. Now you answer, what is this Turing machine going to accept? Okay. Now you answer, what is this Turing machine going to accept? Okay. So Q naught on seeing a leaving it as A and moving right, and on seeing a B, leaving it as B and moving right, and on seeing a leaving it as A and moving right, and on seeing a B, leaving it as B and moving right. Let us say this is Q1, let us say this is Q2, right? And on seeing a blank, leaving it as blank and moving right, and finally it is reaching the final state Q3. Finally it is reaching the final state Q3. Right? What is the language accepted? So you are going to see any number of A's followed by a B, any number of A's followed by a B, and then after this B, there should not be anything. There should be a blank, then only you are going to accept it, right? Therefore, the language accepted is A star B, A star B. That's it. A star B, A star B, right? After this B, it has to see a blank, right? Now, tell me about this. This is a simple Turing machine. Q naught on seeing a leaving it as A and moving right, and it is going to QF, and it is going to QF. Q naught on seeing a leaving it as A and moving right, and then it is going to QF. What is the language accepted by this machine? What is the language accepted by this machine? Right? What is the language accepted by this machine? So, so on seeing a, it is going to final state, and after that, whatever it sees, it is going to die in final state, which means after a followed by anything, this machine is going into final state and halting there, right? So you may think that the language accepted is A, but the language accepted is A followed by A plus B star. But the language accepted is A followed by A plus B star, right? Now answer this question. Q naught on seeing a Q naught on seeing a is leaving it as A and moving right, and then it is going into Q1. Now Q1 on seeing a blank, leaving it as blank and moving right, and it is going into accepting state Q2. What is the language accepted by it? What is the language accepted by this machine? What is the language accepted by this machine? What is the language accepted by this machine? Right? So on seeing a, it will go to Q1. After that, only if there is a blank, it will go to QF, which means A followed by blank is accepted and nothing else is accepted, which means only A is accepted. So the language accepted by this Turing machine is only A. The language accepted by this Turing machine is only A, right? So one thing that is worth noting here is if a Turing machine is moving only in one direction, then the language accepted by it is regular language. Okay. So if a Turing machine, moves, if a Turing machine moves only right, if a Turing machine moves only right, it accepts only regular language. It accepts only regular language. It accepts only regular language. Okay, fine. Now answer this question. What is the language accepted by this Turing machine? Q naught on seeing A, leaving it as A and moving right, and on seeing B, leaving it as B and moving right, and finally it is reaching the final state, right? What is the language accepted by this machine? So what is the language accepted by this machine? Right. So any number of A's, you will be in Q naught, and on seeing a B, you will reach QF. And after seeing a B, whatever you see, you will die in QF, which means after this B, whatever you get, you are going to accept it, right? Whatever you get, you are going to accept it. Hello, Shantanu. So the language accepted is A star followed by a B. After this B, whatever you get, you are going to accept it, right? So A plus B star, whatever you get, you are going to accept it. Whatever you get, you are going to accept it, right? Now let me do a small modification to this machine. So initially you are in state Q naught. On seeing any number of A's, you are leaving it as A and moving right and moving right. And on seeing a B, you are leaving it as B and you are moving right. And you will be in state Q1. You will be in state Q1, right? And on seeing a blank, you are going to leave it as blank and you are going to move right. And finally, you are going into QF, right? So what is the language accepted by this machine? So what is the language accepted by this machine? Try this. What is the language accepted by this machine? What is the language accepted by this machine? Good evening, Kiran. So what is the language accepted by this machine? Try this. Okay, I'll just get some water. You try this. Right? So any number of A's followed by a B, you will be in Q1. After that, only if you see a blank, you are going into final state, which means after any number of A's, when you see a B, after that B, you should not see anything, right? Therefore, language accepted is any number of A's followed by a B. After this, you should definitely see a blank. You should not see anything. That is why it is A star B. That is why it is A star B. Right? Right? Now, let's see this question. Q naught on seeing a, leaving it as A and moving right. On seeing a B, leaving it as B and moving right. And you are in state Q1. And you are in state Q1. Now Q1 on seeing a, leaving it as A and moving right. And on seeing a B, leaving it as B and moving right. And finally, when you see a blank, you are leaving it as blank and moving right, and you are accepting this string, and you are accepting this string. And you are accepting this string. Shantanu, be very confident or comfortable with regular languages and context-free languages. Majority of the questions come there. And from Turing machine, we get questions rarely, right? And they will be very easy questions, right? So regular languages and context-free languages are helpful for GATE 2026, okay? Don't leave out any regular languages or context-free languages, okay? Now, see this, answer this question. So, if the string length is odd, you will get into Q1, right? 1 length, 2 length, 3 length, 4 length, 5 length, 6 length. So, if the string length is odd, you will get in Q1, right? Which means odd length strings you are going to be in Q1, and after that if there is a blank you are accepting it, which means you are accepting all odd length strings, right? So what will be the regular expression for this? Yeah, odd length strings a plus b star followed by a plus b, a plus b, a plus b star followed by a plus b, right? Now if we do a small modification to this machine, right? Q naught on seeing a, leaving it as A and moving right. On seeing a B, leaving it as B and moving right. And now you are in Q1. and now you are in Q1. On seeing a, leaving it as A and moving right. On seeing a B, leaving it as B and moving right. And here, if you see a blank, leave it as blank and move right, and you accept it, right? So, what is the language accepted by this Turing machine? So, what is the language accepted by this Turing machine? So, what is the language accepted by this Turing machine? Right. Now, if you observe it, for all even length strings, we will end up in Q0. For all odd length strings, we will end up in Q1, right? So 0 length, 1 length, 2 length, 3 length, 4 length, 5 length. So Q0 is nothing but all even length strings. Now after seeing even length strings, if you see a blank, you are accepting it. After seeing even length strings, you are seeing a blank. If you are seeing a blank, you are accepting it. After seeing even length strings, if you are seeing a blank, you are accepting it. If you are seeing a blank, you are accepting it, right? So which means for all even length strings, we are going to accept it. So what is the regular expression for even length strings? A plus B, A plus B star, A plus B, A plus B star, which means even length strings, right? Fine. Now I'll give you a question. Try to answer this. Construct the Turing machine for A power n, B power n such that n is greater than or equal to 1. A power n, B power n such that n is greater than or equal to 1. So how do you think we can construct a Turing machine for this? A power n, B power n such that n is greater than or equal to 1. How do you think we can construct a Turing machine for this? How do you think we can construct a Turing machine for this? A power n, B power n such that n is greater than or equal to 1, right? So how do you think we can construct a Turing machine for this? Think about it. Think about it. Think about how we can construct a Turing machine for this, right? So I'll give you some hint. Let us say, there is a daily laborer or daily worker, daily wage worker, and he doesn't know how to count, right? And his boss has assigned him a work that there are there are two rooms. There are two rooms in which one room has bag of sandbags, and other room has bags of cement. Okay, other rooms has bags of cement. Now the task given to this worker is, he doesn't know how to count. He has to he has to say whether sandbags are equal to cement bags or not. Whether sandbags are equal to cement bags or not. He has to say whether sandbags are equal to cement bags or not. Right? How do you think that daily worker will answer it? How do you think that daily worker will answer this question, whether sandbags equal to cement bags or not? He doesn't know how to count, right? Now, if you can answer this question, you can answer this a power n, b power n, right? What could be the way? What could be the way? What could be the way? Right? So, simple way is simple way is you go to the room of sandbags and you mark a bag, right? And again you come to back of cement bags. It can be any mark. It need not be X or Y. It can be any mark because he doesn't know how to read or write. Therefore, he will use any symbol. Okay. So let us say he is using the symbol Y here. And again he will go to the room of sandbag and mark it as X. And again he will come to the room of cement bags and mark it as Y. Again he will go to the room of sandbags, mark it as X. Again he will go to the room of cement bags and mark it as Y, right? Finally, when X and Y, all these X's and Y's are equal, if the bags are over here, you can say that both are equal. He can say that both are equal, right? Now using the same method, you try to find out the Turing machine for a power n, b power n. Using the same machine, using the same method, you try to find out a power n, b power n. You try to find out a power n, b power n. Okay. Try it. Okay. Sir, I am in first year student. How I start gate preparation? So even if you are in first year, we will teach everything from basics, right? So Mohit Joshi, you can join Parakram batch, Parakram 2027 batch, and we will teach everything from basics. Even if you are from first year, you will be able to understand this, right? Hi Mohit. Okay, so what you can do is the same method you can apply here. Now let us say there is A, B, 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 right? And then there are blanks here, and then there are blanks here, right? Blanks are here and blanks are here, right? First you are going to first you are going to make this as X, and you are going to move right and make this as y, and then you are going to move left, make this as x, and then you are going to move right and make this as y, right? So using this method, if all the a's are covered, if all the b's are covered, and if they are equal, we can say that a power n b power n is accepted, right? Now you try the Turing machine for this. Okay, now you try the Turing machine for this. Now you try the Turing machine for this. Now you try the Turing machine for this. Okay. Okay, I will answer this. Just see this. Now initially let us say you are in state Q naught. Initially let us say you are in state Q naught, and initially you are seeing A, right? Initially you are in state Q naught. Let me write it a little bit down. Initially you are in state Q naught and you are seeing a, leave it as A and move right, right? After that, after making a as x, when you are moving right, you can get any number of a's and any number of y's, right? So you can get any number of a's, leave them as a's and keep moving right, and you can get any number of y's, leave them as y's and keep moving right, right? Then finally you may get a b, right? Now what will we do? We will make a b as y and keep moving left. We will make the b as y and keep moving left, right? Now when you are moving left, you may get any number of y's, any number of a's, right? So you may get any number of y's, leave them as y's, keep moving left. Any number of a's, leave them as a's, keep moving left. Now finally you will get a x. Now finally you will get a x. Finally you will get a x, right? So when you get a x, leave it as x and keep moving right. When you get a x, leave it as x and keep moving right, right? Now again you will see a, make it as x and keep moving right. Again you will see a y, y's and a's, keep moving right. Again you will see a b, make it as y, keep moving left, y's and a's, keep moving left. This process will happen forever. Until what time? So until all the a's are made into x and all the b's are made into y. Now what will happen? Now immediately after you see a x, you will see a y, right? Now immediately if you see a x, after seeing a x, if you see a y, leave it as y and keep moving right. What does this mean? This means all the a's are over. This means all the a's are over, right? Now if you see a y, any number of y's, leave them as y's and keep moving right. Leave them as y's and you keep moving right, just to check that all the b's are over. So see that only y's are there, And after all the y's, if there is a blank, it means b's are also over, right? Leave it as blank and you move right. B's are also over. B's are also over. B's are also over. B's are also over. Right? Now in the same way, do the Turing machine for a power n, b power n, c power n such that n is greater than or equal to 1. A power n, b power n, c power n such that n is greater than or equal to 1. A power n, b power n, c power n such that n is greater than or equal to 1. Right? A power n, b power n, c power n such that n is greater than or equal to 1. Such that n is greater than or equal to 1. A power n, b power n, c power n such that n is greater than or equal to 1. Right? So you can mark A's as x, B's as y, C's as z. Now if all the A's and B's and C's are equal, you will get equal number of x's, y's and z's, right? So that is simple logic. Try it. Try it once. Try it. Try this question. So you can take an example and see this. A, B, 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 C, 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 and there are blanks to in the left and right. Okay. Now what will you do? You will make A's as x, B's as y, C's as z. Again move left. A's as x, B's as y, C's as z. Right? Right? So how will the Turing machine look like? So how will the Turing machine look like? Try it. Try the Turing machine. I have given you the hint. Try the Turing machine. I have given you the hint. So how are you going to do this? In the same way, a power n, b power n, you can do a power n, b power n, c power n, right? So initially, let us say you are in state q naught. On seeing a, you will make it as x and keep moving right, right? Now, when you are keep moving right, you will get any number of a's, leave it as a's and keep moving right, and you will get any number of y's, leave it as y's and keep moving right. Then you will get a b, make it as y and you keep moving right. Then you are going to get any number of b's, leave it as b's and keep moving right. And then you are going to get any number of z's, leave them as z's and keep moving right. Finally, you will see a c, make it as z and keep moving left, right? Now, when you are moving left, when you have made c a z and when you are moving left, you will get any number of z's, leave them as z's and you keep moving left. And then you are going to get any number of b's, leave them as b's and keep moving left. And then you are going to get any number of y's, leave them as y's, keep moving left. And then you are going to get any number of a's, leave them as a's, keep moving left, and you keep moving left. Finally, you will get a x and you have to repeat the entire process, right? Finally, when you get a x, leave it as x and keep moving right. Now let us say after the x, immediately y is there. After x, a is not there, immediately y is there, which means a's are over, right? After ax, immediately y is there, leave it as y and you keep moving right. After ax, immediately y is there, leave it as y and you keep moving right. Leave it as y and you keep moving right. Okay. Now, after all y's are over, let us say all y's are over. Okay. So you check if all the y's are over. Leave y's as y's and keep moving right. Check if all y's are over. Leave y's as y's and move right. Keep moving right. And after all, check if all the z's are over, right? For every z, leave it as z and keep moving right. And finally, if you get a blank, leave it as blank and move right and you accept. Leave it as blank and you move right and you accept. Leave it as y and you move right and you accept. Now let's see Turing machine as a transducer. Turing machine as a transducer, right? Now what is transducer? Transducer converts input to output, right? Transducer converts input to output. Acceptor will accept or reject a string, but transducer will take a input and convert it into output, right? And convert it into output. So you don't have to have a final state here. Even if you have final state, it doesn't make any difference. If you want to have a final state, you can have it, but it is not required. You are going to convert input to output, right? Now let us say we are doing addition, right? F of x comma y is equal to x plus y. Let us say we are doing addition, right? Now f of 2 comma 3 is equal to 2 plus 3. F of 2 comma 3 is equal to 2 plus 3. F of 2 comma 3 is equal to 2 plus 3, right? that equal to 5. Now how is 2 and 3 represented on a Turing machine is 2 is represented by 2 ones followed by a 0 and 3 is represented by 3 ones, right? Now this input should be converted to 1, 2, 3, 4, 5. Now when you are talking about a transducer, after input is converted to output, you have to point the input pointer to the beginning of the output. After input is converted to output, you have to point the input pointer at the beginning of the output. At the beginning of the output. Okay? At the beginning of the output. Right? Can you try this? Try to convert 110111 to 111 followed by 11. Try this. Right? Okay. So let us see this. Initially you will be in state Q0 and on seeing ones, any number of ones, leave it as ones and keep moving 0. Now when you see the first 0, make it as 1 and you keep moving left, and you are going to see any number of ones, leave them as ones and you keep moving left and finally you will see a blank. When you see a blank, leave it as blank and you move right, which means you will be at this one, right? Now make it as blank because you have added one extra one, so you have to make one as blank, right? Now when you see the 1, make it as blank and you move right. So you are going to make it as blank and you move right. Now you are going to have 5 ones. That is what is needed, right? So you can end in a state. Anyway, you don't have to make this as final state, but even if you make it as final state also, it doesn't matter much, right? You can make it as a final state also, it doesn't matter. Okay, so finally the 1 is made to blank, this one is made to blank. Okay, and then you are going to halt here. Even if you make it as a final state, it doesn't matter, but input is converted to output. Okay, fine. So we'll see the remaining topic tomorrow. We will end this session here. Thank you, good night and Jai Hind. Okay.